Hi friends and neighbors, welcome to the 7th ShepNotes video on a series covering statistics and probability. This video will review permutations and then cover combinations. It will also start with a summary of the current 20 ShepNote videos. This is the 20th ShepNotes video, so I will start this one with an index of the videos made up to this date. The first group of videos shows the ones from ongoing statistics series. As you look over the list, the particular subjects seem to jump around with similar subjects scattered around. Some subjects are spread between adjacent videos. These are arranged this way, like sets in video 3 and 4 of this series, to keep the lengths of the videos short to meet the YouTube requirements for videos less than 15 minutes, and also to take natural breaks when more material on a subject needs more information on another subject before moving on. For example, probability is introduced in video 3. More advanced discussions on probability rely on understanding other supporting items, and these discussions will be presented after these supporting items are covered and explained. For example, some discussions of probability include the use of supporting items like factorials, permutations, and combinations, so these discussions on probability are delayed until after the supporting items are discussed. Several ShepNote videos do not cover statistics, but cover various other subjects of interest. There are 2 covering batch commands on the TI Inspire calculator, 2 on stereochemistry, 1 on acids and bases, 1 on Roman numerals, 3 on seeing how we see, 2 on genetics, 1 is a Visio Shapes catalog, and the last one covers Excel times and dates. Although new videos may be added to the group of subjects, focus is currently on creating a comprehensive collection of videos on the various aspects of statistics, probability, and all of the supporting subjects required for a useful understanding of statistics. Before we tackle combinations, let's make a review of permutations. The number of possible permutations of n distinct objects is n factorial. These permutations are the number of arrangements where the order of the arrangement is important, and we are interested in all of the possibilities. The actual permutation formula allows for calculating n objects taken r at a time. NPR equals n factorial divided by the quantity n minus r factorial. When r is set to n, it becomes the simpler formula NPR equals n factorial over the quantity n minus r factorial, which is equal to n factorial divided by n minus n factorial, which is equal to n factorial divided by 0 factorial, which is equal to n factorial divided by 1, which in turn is equal to n factorial. For 10 unique items, the number of distinct arrangements or permutations is 10 factorial, which is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to 3,628,800 different ways to arrange these distinct items. If we want to use 2 of these 10 items in a document, the number of different permutations is 10p2, which is equal to n factorial divided by n minus r factorial, which is equal to 10 factorial divided by 10 minus 2 factorial, which is equal to 10 times 9 times 8 factorial divided by 8 factorial, which is equal to 90. There are 90 different combination of symbols we can use when we are taking 2 of the 10 at a time. There is a simple trick you can use when you are calculating the permutations of r of n objects, like 2 of 10 in this example. 10p2 is equal to n factorial divided by n minus r factorial, which is equal to 10 factorial divided by 10 minus 2 factorial, which is equal to 10 times 9 times 8 factorial divided by 8 factorial, which is equal to 90. What you're actually doing with this formula is using the first r factors of n factorial. The first two factors of 10 factorial are 10 times 9, or 90. For example, the number of permutations of 5 objects taken 3 at a time is simply the first 3 factors of 5 factorial, 5 times 4 times 3, which is equal to 60. Okay, let's look at the difference between combinations versus permutations. At the upper left, we are showing 3 permutations and 1 combination of 3 colored objects in the image. With permutations, order is important. At the upper left, there are 3 permutations of the 3 colored objects, since each group is arranged in a different order. With combinations, order is not important. Each group of objects at the upper left is the same combination of objects, since the only difference between the groups is the order of the objects in the groups. In permutations, if we take 3 of the 5 letters A, B, C, D, and E, there are 4 times 3 equals 12 different arrangements, like ABC, ACB, BAC, and so on to DEC and CDE. Order is important, and we care about which is first or second. In combinations, when we take 3 of the 5 letters A, B, C, D, and E, we don't care which is first or second. We are only wondering how many combinations of 3 letters can we take out of the group of 5. ABC, ACB, BAC, etc. are all only one of the combinations, since the specific letters are all the same but arranged in different orders. Another different combination is BDE, DEB, BED, etc. Combinations are essentially permutations where we don't care about the order. Taking 3 letters at a time from A, B, C, D, and E, there are 5 times 4 times 3, which is equal to 60 permutations. Since order is important in permutations, the permutation calculation includes each combination of letters, like A, B, C, more times than they actually exist by a factor of 3 factorial times, which is the number of permutations of each 3-letter combination. To correct the overcount of 3 factorial combinations when there should be only 1, divide the permutations by r factorial to get the correct number of combinations in the calculation. NCR is equal to NPR divided by r factorial, which is equal to n factorial divided by r factorial times the quantity n minus r factorial. Hi friends and neighbors, thanks for watching the 7th ShepNotes video on my series covering statistics and probability. This video reviewed permutations and then covered combinations. It started with a summary of the current 20 ShepNote videos.